This is problem number 7 on the sample test problems for test number 2. A certain 4-member mathematics department makes all its decisions by voting. The department chair receives 7 votes. The former department chair who's about to retire receives 4 votes. The professor who just got tenure receives 2 votes. And the professor who was just hired last year receives 1 vote. The department requires 9 votes in favor of a motion for it to pass. A. Express this situation using our notation for weighted voting systems. So what we need to do is start with a square bracket. Remember, there's some number, and then there's a colon, and then there's a bunch of other numbers separated by commas with a square bracket. So we just need to put these numbers in. The first number in the bracket there is the quota. It's the number of votes required to pass something. So there's our 9. And then the rest of the numbers are just the number of votes that each person has, that each player has. So we've got 7, 4, 2, and 1, and we always write them in decreasing order, so in that order with commas separating them. Part B, how many coalitions are possible? So we have a formula. Oh, and then the other part, how many sequential coalitions? So we had 2 different formulas for these problems. So the total number of coalitions, we had this formula. It was 2 to the n, 2 to the number of players involved, and then subtract 1 when you're done. So in this case, we had how many people voting? We had 4 people voting. So it's 2 to the 4th, and then minus 1 when we're done. Remember, the order of operations says we have to do the exponent before we do the subtraction. So 2 to the 4th is 16. Subtract 1 is 15. So there's 15 different coalitions. But then if we talk about ordering the coalitions, meaning everybody is voting in favor, but we want to put them all up in the different orders, this is a different formula. This is n with an exclamation afterwards, which means n factorial. N is still the number of players, which is still 4. So 4 factorial. And what that means is you start with 4, and then you multiply by 1 less, and you multiply by 1 less, and keep going until you get down to 1. So 4 times 3 times 2 times 1 is 24. And I just want to point out that we actually can see those 2 numbers. Just kind of looking ahead, I've copied and pasted some stuff from the first page of your packet. But I just want to highlight that, for example, this 15, that's the number of coalitions of any groups of players. You'll find them here. There are 4 singletons, and then looks like 6 pairs, and then 4 triples, and then the single coalition of everybody. So 4 and 6 and 4 and 1 is 15. So that's that 15. And then the 24, we'll find down here, the list of all the ordered coalitions of all 4 players. And if you count all of these things up, you will find 24 things in that list. Okay, part C. Find the Bonzoff power distribution for the mathematics department. Okay, you will have the first page of the packet with you, so in theory that tells you exactly how to do this, but certainly you want to practice before you get there to the test. So the Bonzoff power distribution involves listing all the winning coalitions and then finding the critical players. So first thing we need to do is think about which ones of these 15 things that are listed here is actually a winning coalition. So let me put it up here, the notation we had written up above, 9, 7, 4, 2, and 1. So first, is there any single player? I'm looking in this first column here, and I want to know if any of those single players is a winning coalition by themselves, and the answer is no. Even the most powerful member of the department has 7 votes, which is not enough to pass anything. So are any of these things here winning coalitions in the first column? The answer is no. So I'm just going to cross them off. They don't even get considered. And then we look at the second column, and we're looking for all winning coalitions. You're welcome to just list these things instead of crossing them off like I'm doing. So listing the winning coalitions, for example, the P1, P2, which is the first 2 folks, 7 and 4 is 11, that's enough. That's a winning coalition. First and third, that's 7 and 2, that's a total of 9. That's enough, just barely, but that passes. First and fourth, 7 and 1 is 8. That's not 9. That's not enough. That's not a winning coalition. And then we keep playing this game. Players 2 and 3 have only 6 votes. That's not enough. And if you keep going down the line, I think you'll see that these are getting actually weaker, so none of those wins. Then we look at the trios, and you play the same game here. I'm just going to cross off anything that didn't work. And so what doesn't work here, let's see. If you look at this bottom one, which is players 2, 3, and 4, altogether 4, 2, and 1, that's only 7, so that's not winning. Cross it off. But I think everything else there is winning. And then finally, the last coalition with everybody in it has plenty of votes to pass, so that's a winning coalition as well. So whether you do it by just listing these things from scratch, or you do it by starting with the first page of the packet and then crossing off the losers, we should end up with this list of winning coalitions. Now what I'll do is think about who the critical players are. So I'm going to say a lot and write down very little, so I hope this stuff makes sense. But this is the trickiest part here, is finding the critical players. So if we were to start with this first P1 right here, and we were to decide to cross them off, then we only have left P2, which only has 4 votes, which is not enough to pass the thing. So crossing P1 off turns that coalition from winning to losing, which means P1 was really important to be in this coalition. P1 is a critical player. You can play the same game with the rest of these. So go ahead and pause the video here. I'm going to just do this column real quick, but pause the video if you want to try it on your own. And I think what we'll see is that every one of these players in this column is critical. So I'm going to circle them all. And now we'll go to the next column, and I'll do the first one in a little bit more detail, and then we'll zip through the rest of them. So if we take a look at P1 and try to cross it off, we have left P2 and 3. Second and third players have only 6 votes, which is not enough, which means tossing out P1 is a problem. P1 is critical. Now we try to toss off P2, but P1 is now back in the mix. So if P2 is out of here, then we've got P1 and we've got P3. P1 and P3 have 7 and 2, that's 9 votes, that's enough, which means P2 is not critical. We could lose P2 in this coalition, but it still wins. Another way to see that is that P1, P3 is listed over here as a winning coalition. However you do that is fine, but whatever you do, don't circle P2 because they're not critical. Likewise, P3 is not critical. Okay, so again, I'm going to do the rest of this column here. If you want to pause the video and try it first, then do so. Okay, in the next coalition, I think we find that P1 is critical, and P2 is also critical, but P4 is not. In the next coalition, P1 and P3 are critical, but P4 is not. And then we come over here to the last coalition. If we try to cross off P1, then we have left 2, 3, and 4. Those guys have only 7 votes total, which is not enough. P1 is critical. But if you were to try to cross off P2, then I think these folks still have enough power to pass the thing without P2. If instead you were to bring P2 back and cross off P3, they have enough power to pass without P3 in there. And the same thing is true for P4. So nobody else is critical there, just P1. Okay, so we've circled our critical players. Now it's up to us to try to figure out what the power distribution is. So we're looking for fractions here. First thing to do is count how many times each player is critical. So P1 is circled how many times? It looks like 6. P2 is circled how many times? Twice. P3 is circled twice. And then P4, not circled a single time. That's 0. Please don't forget that these power distributions are fractions. They're not just single numbers sitting up there, they are fractions. So on the bottom goes the total number of times that anybody was circled. So if you count all the circles, you will count 10. Another way to get to 10 is to add these numbers that are written in purple already. 6 plus 2 plus 2 plus 0. So here's our power distribution. P1 has 6 out of 10, which is 60% of the power. P2 has 20%. P3 also has 20%, and poor P4 has no power at all. Let's move on to part D. Find the Shapley-Shumac power distribution for the mathematics department. Again, I've copied and pasted something from the first page of your packet. On the test, I think I would probably just give this to you as part of the test itself. Okay, so the idea here is to find, assume now that everybody's in favor of the motion that's on the floor. And so at some point, the motion is going to pass. And the only question is, who is the person who pivots the scale? Who's the person who turns it from a losing coalition into a winning coalition? And that person is called the pivotal player. So our job is to circle the pivotal player in each of these different rows, these coalitions. So what we're going to do is we're going to move this. So what we're going to do is we're going to list up above each player's name how many votes they have. So for example, player 1 has, let's see up here, 7 votes. So every time I see a player 1, I'm going to write a 7 right above their name. 7's all the way down. And I'm going to go ahead and then we'll do the same thing with player 2. Player 2 has 4 votes, so every place I see a player 2, I'm going to put a 4 on top. That's not right. Put a 4 on top, every player 2. So I'm going to pause the video here and fill these in. I'd encourage you to fill them in as well, and you can pause the video and then come back when you're done. Okay, so I've filled in all of my numbers, except for 1. Let's fill that in. So we filled in all the votes, and now what we need to do is look at each of these 24 different coalitions and decide who's the player who turns it from a losing coalition to a winning coalition, and then that player gets circled. Or I'm actually going to highlight each of the winning players. So let's take a look at, again, the quota. Quota here is 9. So the goal is to get to 9. So in this first row, so we're looking right here. The first voter has 7. That's not enough. That's only 7. We need 9. The next voter throws 4 onto the pile. That brings us to 11. That makes that person critical. Pivotal. So player 2 in this case is the one who gets us over 9 votes. In the next row, 7 is not enough. Add another 4. That's more than 9. In the next row, 7 is not enough. Add another 2. That gives you 9. That's good. In the next row, 7 is not enough. Add 2, you get 9. In the next row, 7 is not enough. Add 1, that's only 8. It's still not enough. Add another 4. That brings you to 12. That's enough. Last row here, 7 is not enough. Add 1, that's 8. That's still not enough. Add 2, that's 10. That's enough. So I'm going to ask you again to pause the video, and I'll do the same. And then we'll just fill in the rest of these, and then you can compare which ones you think are pivotal with the ones that I've got highlighted up here. Okay, so I've highlighted all the players that I think are pivotal. So take a moment, maybe pause the video here if you'd like, and compare your answers to mine. And now that we've got all the pivotal players circled or highlighted, again, our job is to come up with fractions, just like we did up above, to represent the power distribution. So we'll list our 4 players again. And our job is to first count how many times each player is pivotal, each player is circled or highlighted. So P1, if you count all the places P1 is highlighted up on my list, I think you'll find that they are highlighted 16 times. P2, if you count all the P2s that are highlighted, you'll find there are 4 of them. P3 is also highlighted 4 times. And poor player number 4, not a single highlight. Again, these player distributions, these power distributions are fractions. So we need to divide. You can divide by the total number of things that were highlighted in my picture or things that were circled on your paper, or you can recognize that there are 24 things in this list, and so that's what goes in the bottom here. These answers are fine, but if you liked writing things as percentages, 16 out of 24 is 2/3, which is roughly 67%. 4 out of 24 is 1/6, which is right around 16. Right around 16%. That's also right around 16%. And again, player 4, 0%. Part E, name any dictators, dummies, and players with veto power. Okay, a dictator is somebody that has power to pass the motion by themselves. Even our strongest player, which is player number 1, has 7 votes, which is not enough to pass this thing with the quota at 9. So there are no dictators. A dummy is somebody with no power. You can see that player number 4 got 0% of the power both times we did this calculation. So player 4 is a dummy. And any player with veto power, so here we're looking for somebody that is in every single winning coalition. Somebody who has the possibility to stop the thing from passing single-handedly. And so if you take a look at our list of all the winning coalitions, there actually is somebody who's in every single one of these winning coalitions, and that's player 1. Nobody else is in every one. For example, player 2 doesn't exist in this one. Player 3 doesn't exist in that one. And player 4 is missing from several of them as well. But somebody who's in every single winning coalition, somebody who's necessary to make the thing pass, has veto power. So player 1 has veto power. Another way to see that is that if you look at everybody else and you add them all up together besides player 1, they only have 7 votes, which is not enough. So those 3 people cannot band together and pass the thing. They need the help of player number 1. But if you looked at a different group of 3 people, for example, those 3 people, they have enough power. So player number 2 with 4 votes does not have veto power. They're not necessary to win every single coalition. So who has veto power? In this case, it's just player 1. Part F, give another conclusion about the department which you can draw from looking at the Bonzoff power distribution, but was not obvious from the vote totals. So again, I'll write down the vote totals here. It was a 7, 4, 2, and 1. So a couple of different observations you could make here. It looks like player number 2 should be stronger than player 3, but somehow player 2 and player 3 have equal power. You can see that up here. Player number 2 had about 16% of the power, and so did player number 3. That was doing the Shapley-Shumac. Up above, they both had 20% of the power, but they were equal to each other. And that's kind of a surprise looking at the numbers. That 4 and that 2 doesn't seem like they should be equal. Something else you could say is player 4. It looked like player 4 had some power. Player 4 at least got a vote, but it turned out that player 4 had no power at all. And that was not obvious looking at the voting totals.